Okay, so we're going to be talking about solving systems by graphing. We have three different types of solutions. The first solution, if you look to the left over here, it's one solution. This is exactly what we're going to look for when the lines intersect. Where they intersect, that point, that means that that is a solution to both equations. Let's look at the one in the middle. Now, when you graph the two lines and they turn out to be the same line, that means there's infinitely many solutions. Every single point on that line is a solution to both. Well, because they're the same. Then if you look at the last one, it says no solution. This one makes sense because we've talked about parallel lines. Parallel lines never touch. They never meet. They never cross. So therefore, there's going to be no solution that will satisfy parallel lines. What is the solution of the system? Use a graph. All right, here I have two equations. They're both in slope-intercept form. So we're going to graph them and we're going to see where they cross. Now, you guys know how to graph by now. The 2 is the y-intercept. The 1 in front of the x is the slope. And the -2 is the y-intercept. And the 3/1 is the slope. So we just graph. And they cross. They do intersect. They intersect right here at point 2, 4. So then that means if you plug in 2 for x and 4 for y into both of the equations, you'll see that it works in both equations. So that means the solution of the system is 2, 4. What is the solution of this system? Use a graph. Same thing, we have a y-intercept and we have a slope for each one. And if you graph them, they're going to intersect right here at -2, 0. So when you plug -2 in for x, 0 in for y, -2 in for x, 0 for y, you will see that it does work in both equations. So the solution to the system is -2, 0. Now we have an alligator situation here. We have scientists studying the weights of 2 alligators over a period of time. Alligator 1, this is his table with his weight. Alligator 2, this is his table with his weight. It wants to ask how many months did the alligators weigh the same amount? Well, this is easy. First of all, we need to find an equation. We just have a table. Now, we're very lucky because it has a 0 and a 4. So we know that 4 is the y-intercept for alligator 1. And we know that 6 is the y-intercept for alligator 2. Now we just need to calculate the change in y over the change in x. So 1.5 over 1 will be our slope. And over here, 1 over 1 will be our slope. Okay, so when they break it down, they tell you the alligator weight is initial weight plus growth weight times time. Okay, so they're breaking it down really nice and neat for you here. So the alligator 1 was 4. That was its initial weight. Remember, that's our y-intercept, 4. And our change in y over change in x was 1.5. And 6 we said was our y, and 1 was our change in y over x. So here are our two equations. Easy again. Already written in y-intercept form, we just graph them, right? Slope. Now to change 1.5 into slope, that's easy. 3/2. Okay, you don't go up 1 and over 0.5. You go 3/2. Okay? And then when you graph, here is alligator 1. Here is alligator 2. So after 4 months, right here where they cross, each alligator will weigh 10 pounds each. Okay? Now here's one about satellite radio service. Same thing, okay? There's 2 decisions that you need to make here. Radio service 1, radio service 2. You have a table. So again, you're going to calculate your rate and change, right? Y over x and your y over x, right? Now, we don't have 0 on the table, so we have to calculate what 0 is. So at 0 months, this is going to be $20 because see how these are increasing by 10? I just subtract 10. So at 0 months, it's going to be $20. Over here at 0 months, I'm going to subtract 11, and that's going to be 15, right? 15 and 10, okay? And 10. So I have 10x plus 20 for my first one, and I have 11x plus 15. These are my y-intercepts. These are my slopes. And when you graph the equations in the coordinate plane, you'll see that they intersect at 570. So, in what month will the cost of service be the same? Well, it's going to be the 5th month. Then it'll be $70. So now here, what is the solution of each system? Use a graph. I have this, but this is in standard form, right? And then I have y equals 1/2 x plus 1. Well, I have to change this over so that I can graph it. So that means I'm going to have to isolate the y. So you're going to add the x over. So you'll have x plus 2. And then I'm going to divide by 2, right? So I'm going to get 1/2 x plus 1. So wait a minute. These two are the same exact lines. So when I graph them, they're going to be the same exact line, okay? So here's the first one. And then when I graph the second one, it's going to be the same line. So there's infinitely many solutions, okay? It's the same line. It's infinitely many solutions, okay? Now, what is the solution of this system? Well, I gave you all the answers already. So you have y equals 2x plus 2 and y equals 2x minus 1. Well, this one starts at 2. This one starts at -1. They have the same slope, so they're parallel. So there is no solution. What about this one? This one I have different y-intercepts, but I have the same slope. So what do you think this one's going to be? They're parallel. Different y-intercepts, same slope. So the system has no solution. Okay? So the answer would be B. The lines are parallel. Okay, one mountain climber is 7 feet below a ledge climbing up the mountain at a rate of 3 feet per minute. So there's our x, rate, 3 feet per minute. He's starting 7 feet below. The second mountain climber is 7 feet above. So we have a -7 and we have a +7. And he's descending at a rate of 0.5 feet per minute. Okay, so there's our x. When are the two mountain climbers at the same height relative to the edge? When are the two mountain climbers going to be at the same height? Okay, so here I have 3x minus 7, right? Because he's at 7 feet below and he's ascending, he's climbing up at +3 feet per minute. Then I have a -0.5 because he's descending, that's going down at 0.5 feet per minute, but he's already 7 feet above the same ledge. Okay, so here are my two equations. Now when I graph them, this one starts at -7, this one starts at 7. They have different slopes, so they will cross. They will cross. Now where are they going to cross at? All right, so the answer is 4, 5. So when you graph it at 4, right? When x is 4, y is 5 for both equations. So after 4 minutes, the mountain climbers will both be at 5 feet above the ledge. So now let's look at these two equations. It represents depth of two anchors, okay? So it says how many seconds are the anchors at the same depth? Well, I have two equations here. All I have to do is graph them. I start here at -2, and I have a slope of -1/1. I start here at +6, and I have a slope of -5. So they will intersect. They are not parallel because they have different slopes. So when you graph them, you'll see that they'll cross at 2, -4. So after 2 seconds, each anchor is 4 feet below the water. Last one. You have 100 coins worth $6.95. All of the coins are nickels and dimes. So I have nickels and dimes. I have two different coins. How many nickels and how many dimes do you have? So basically, I'm going to write a system that represents this situation, and then I'm going to estimate the solution using a graphing calculator. All right. So I have to pull out at least two equations. The first one is going to be for the coins. The second one is going to be for the money. So if I have 2 coins and I have 100 coins total, that's going to be x plus y equals 100. I have x dimes, y nickels, and I have a total of 100 coins. The second one, right? Nickels are worth 5 cents and dimes are worth 10 cents. So I have 10 cents per dime and 5 cents per nickel, and I have a total amount of $6.95. So now I have my two equations, and I can graph this. In your graphing calculator, you can graph these equations without having to change them into y equals mx plus b. And then you're going to see where they cross. And we can do this one in class tomorrow as our warm-up. The answer will be 3961. Okay, so when x is 39, y is 61. So this solution right here, 39 dimes and 61 nickels, will satisfy both of these equations because 39 plus 61 adds up to 100. 39 times 10 is $3.90. And 61 times 5, they'll both add up to $6.95.